Hello everyone. For all those who are watching the recording, we'll just wait a couple of minutes if others join. This session was supposed to happen on Tuesday, but due to some unseen circumstances, it couldn't happen then, so it is scheduled for Friday, 1st of September. As everyone would have got the mail with the link and timings. So let's just wait for a couple of minutes if others join. Hello. We are just waiting for others to join.
Okay, sir.
Guys, already half of the sessions have been over. So, how has it been for you? Is it worthwhile spending 2 hours extra, or do you guys need something else? Are the sessions reaching out in the helpful manner as they were planned?
Yes, sir. For the assignments, we are very helpful. It is very helpful, the sessions.
Okay, thank you. Any questions, any problems related to assignments that you already submitted till now? Or of the previous contents that would like further discussion?
Not from my side.
Okay. So we'll just start at 6:05 in 40 seconds or so. Okay. Good evening, guys. Welcome once again to the session. This is the course is Principles of Construction Management by Professor Sudhir Misra at IIT Kanpur. I am Venugopal Mahajan, a PhD fellow at IIT Delhi. This is regarding week 5 contents. This session was scheduled on Tuesday, but due to some unavoidable circumstances, it had to be rescheduled to today, Friday, 1st of September. So we will be discussing week 5 contents, but going with the flow about the course. Here we are covering the breadth, as you will see, even in today's topics. Week 5 planning and scheduling part 2. In part 1 we have seen network diagrams, network analysis, and something about PERT also. So what do we have planned for today? Project monitoring and control, very big term, monitoring and control both. Some resource leveling, okay, or I would call it resource scheduling, because we will be discussing allocation also, and crashing. So I have one question for you guys. Project monitoring and control, till now the exercises that we did were kind of the planning phase. So when should we actually monitor the project? Simple. When should we monitor? Anybody? Okay. See, monitoring is basically how much tight rein you actually want on the project so that it doesn't derail. That basically governs the scale of monitoring, even with your levels, even with your schedules. Like, at what intervals do you want the data to be there? It can be real time, it can be same day, or it can be fortnightly, monthly. It depends on the phase of the project, also depend on the criticality of the activity also. So we will move on to one numerical. Yes, for you guys it might be that okay, we have solved the assignments and this was not there in our assignments, but yeah, this is the kind of thing that you can find in your exams. So we will be discussing it with uh, a numerical. uh, a contract comprising of 4 activities has to be completed in 6 months. You have been given the plan for each month. The total cost has been given to you. What has been asked is prepare the S curve. What is the S curve here? S curve is the baseline related to which we will compare what is the status of the project. Okay. In this case, if we prepare the baseline at this stage, it would be the baseline. Okay. Then what next? For the given two scenarios, we have been given two scenarios with percentage of activities complete at a specific time, and cost incurred till date is also given to you. Like at the end of month 3, cost incurred is this much and the activity complete is given here. Comment if the project status, comment on the project status with respect to schedule and budget. So some figures are given to you. So the question here is when do you, either see, if you're talking in terms of cost, either it could be over budget, under budget, or what? Is there any other option? What about schedule? It can also be right on the budget. Okay. Similarly, for the schedule, you could have those 3 options, right? So how do you actually comment whether it is whether you have exceeded your schedule, or whether you are following your schedule, or whether you are faster than your schedule? So let's try to compare this. First of all, S curve. S curve is in terms of cost. Okay, cost, and especially cumulative cost. We are not worried about specific activities here. We are worried about the cumulative cost or the total cost till that moment of time. Okay, so let's do one thing. Let's convert all these values into cost first. So how will you convert it? It would simply be 15% of 2000. So 300. Similarly 600, 800, and 300 again. For activity B, 600 and 900, 1200 and 300. Similarly, for activity C, this would be 400. So if you have to take the cost per month cost, how much it would be? For M1 it would be 300. For M2 it would be 6 plus 6 plus 4, 1600. For M3 it would be 2100, and so on. And if you have to give the cumulative cost here, So for M1 it would be 300, right? For M2 it would be 300 plus 600, 1600, right? So 1900. For M3 it would be 1900, the previous value, plus 2100, so 4000, and so on, right? So if we have these values, you get this kind of a table. You have got monthly cost, then you have got monthly total and cumulative cost. So if you have to plot the S curve for how the duration would be 6 months, right? So let's make it 1 2 3 4 5 6. And what are the values? We have to go till 100 from 3, right? So for the first month it would be, let me just mark it, I hope this is big enough, 20 40 60 80 and 100. Okay, so for first month it would be very low, 3. For month 2, around 19, 3 4 5 6. Then for month 3 we have got 4040. For month 4, 65, so somewhere around here. For month 5, 880 88, so somewhere near the mid. And for month 6 we have got 100. So how does your curve look like? Yeah, so I have deliberately tried to give it a S shape, because as the name suggests, this is a S curve. So what this shows is, this is your baseline, right? So if this is your baseline, let's try to this solves our first part. Now we have to compare our scenarios. What this shows is scenario 1, end of the month 3, cost incurred is 4500, right? So at the end of month 3, according to your scenario, you are at this point, right? Now the question arises, comment on are you on schedule, behind the schedule, over budget, under budget? So what can you say? From the graph itself, if you see, it looks like till month 3 you should have spent only 4000, but you have spent 4500, so you have gone over budget. Is that so simple? No, it isn't. Now let me give you an example. You had to 3 months to complete a project with 1000 rupees each month. Okay, by the end of, so 33% you are completing each month. So let's say by the end of second month you complete 80% of the project, and similarly the cost too is also 2400, right? 80% of 3000 was your total cost. So what would you say? You're definitely not by comparing this, just by this you would have said I should have spent only 2000 rupees, but I have spent 2400 rupees. So only by looking at the cost you cannot comment on this, right? You also have to see this percent. Yeah, so okay, as we are just a couple of us, I will go back to the question for you what we are dealing with. Okay, so we have been given a project of 4 activities, and we had to comment on various scenarios. This is related to project monitoring. Okay, so what we did was we first converted all the percentage to the cost and cost to cumulative cost, and from cumulative cost we plotted the S curve. This was our baseline, right? Because this is the planned activity. Now we have been given two scenarios at end of the month 3 and end of the month 5. So just a moment please. Yeah, so after plotting the baseline for scenario 1, what you can see, the cost incurred is 4500, but what was planned was 4000 only. So are you over budget or under budget? What we just saw with this example was that, let's say you have a project with one activity for 3 months, uniform activity, 3000 rupees cost, 1000 rupees cost is to be incurred each month, and work is also 1/3 each month. So now by the end of month 2, if you finish 80% of your work, you might incur 2400 cost, but you were supposed to incur only 2000. Can you say that you are over budget? No, because you also performed that much work, right? So what we need to do is we need to also compare what was the actual work performed. But in this case, there are more than one activities. So how do we do it? We convert the work performed into cumulative cost of work performed, right? So let's do it. A 90%, so total cost was 2000, so that brings us to 1800. B 80%, so 2400. C 25%, 1000. So work performed, so cost of work performed is this how much? Sorry. Yeah, 18 plus 24, 42 plus 1000, 52, 5200. But your cost incurred is how much? 4500. So that means the cost of work performed is higher and cost incurred is less. So are you over budget or under budget? See, it is quite in front of you, both the values. Okay, so as you can see that cost of work performed is planned cost is more than the cost incurred, so you are under budget in first case, right? And similarly you are ahead of the schedule because planned was 4000 only. So that is what for scenario 1. Now if you take scenario 2, cost incurred is 8500. At the end of month 5 it should have been 8800. So at the end of month 5 you have reached somewhere here, right? Now the point is, did you overspend? Are you behind the budget? Are you behind the schedule? So let's calculate it again. 100%, so 2000 for 90%, 2700. This is 3600. What about 70%? So this is 700. How much does it come out to be? 36 plus 7 for, yeah, 43, 53, 63, 79. So cost of work performed is 9,000, cost incurred is 85,000, so 8500. So you are still under the budget, right? But similarly, cost of work performed 9,000, planned was 8,800, right? So that means you are again ahead of the schedule. So hopefully you can get an idea from the S curve itself. So we will be limiting ourselves in the monitoring, project monitoring, for this part only. Now coming to resource leveling or resource scheduling. Till now what we were doing was, we were not worried once we calculated the duration. We were not excuse me, yeah, we were not worried about the resources, right? First of all, while calculating the duration, we calculated what was the total quantum of work. We fixed that, okay, this will be the resources, this will be the technique we'll be using, and by that we calculated, okay, this will be the duration, and just forgot about the back calculations. We just moved on. But what if on site, excuse me, so what happened is, when we did all the network analysis, we were not worried about the number of resources. What we assumed was, whatever we have planned for, that will be available to us on site. Okay, well and good. I mean, if you're talking about some common resources, it can also be possible if you have got abundance of resources, and especially markets like India, where you, if you're talking about labor as a resource, it might be the case that in some seasons you have got extra labor available, while in cultivation season the laborers are less as they have gone to their farms. So yeah, it could be the scenario. But what if the resource is limited? And even if the resource is not limited, it could be such that on one day you have got, on first day you have got requirement for 10, for next day you have got requirement of 20, next day you have got requirement of 50, 50, then next day again you come down to 5, then you come down to 25. So even if someone supplies you labor, he might not be in the he might not have good image for you, like if you have such a variable demand. So what you would like is, and you would also not prefer this kind of distribution, because that means your mobilization cost is varying, even your all the other mobilization cost or training costs, they are going to change. So what you would prefer is, you would prefer that, okay, instead of having such a variable demand, let's have it uniform, somewhere around 30, 35, 35, let's say. So if this is a uniform demand, you would be happy with it. So what we did right now is, we compressed the peaks, right, and brought up the troughs. So this is resource leveling. Okay, but we didn't change the duration. The duration was fixed, right? But what if someone comes and says, yeah, the labor contractor is not able to supply you more than 30 labors for the duration? Then what can you do? You will have to make sure that in 30 labors you complete your task. So what would happen is, your duration would increase, right? So this is an example of resource allocation. So we will see both these in a numerical, and this is going to be a like rest of the two numericals as the two topics are. This is going and they are going to be lengthy and boring. So I request you to help me in solving them faster. Okay. So what have you been given? For the given project, determine the resource profile for this project. If the activities are to start on their earliest start time, okay, you have to prepare a resource profile. What do you mean by resource profile? The one thing that we saw here, each the resource loading chart, the number of resources needed for each day. If the activities start on their latest start time, and then we have to try to optimize it, and we also have to prepare a schedule if maximum available resource is limited to 10 days, 10 per day. So this is the case of allocation, and this one is of leveling, right? So what we would do is, what should be the first step? You have been given activity, IPA, duration, resource required per day. What should be the first step? To know their EST or LST, right? Excuse me. So this is the kind of chart. The network diagram I have made, AON it is, right? Durations are given. Let's just derive its EST and LST. 0 1 1 1. Yeah, help me check the calculations. Okay, 5 4 3 3. What about this? This comes to 5 and 2 7, 4 4 plus 2 6. This becomes 3 plus 3 6. What about this now? It comes 6 from both sides, right? Yeah. D and F, let me check. D and F are 2 and 3, and C and E are 3 and 2. Yeah, okay. What about I now? It starts at 6 and ends at 7. What about J? So it is 7 and 3, 10. So total duration is 10. What about the critical path here? So in this case, if you backtrack, you can see that ACEI, ACEIJ or ADFIJ, both are the critical paths here, right? And this is your early start time. So let's start plotting them. Okay, so I will just name them A, B, C, D, E, F, G, H, I, J. This would be your total, and let's have the days. 1 2 3 4 5 6 7 8 9 10. 10 would be enough, right? So if you go by your early start time, right? So A start on 0 day, right? And the duration is 1. Do we really need to look into this box, this network again and again to complete this table? That is my question to you. So resource required is 7. Yeah, for now, activity B, C, D, they all start on end of the day 1, so start of the day 2, go till 5 4 3 and 4 3 2. Okay, so 432 and right. So is it done? D duration of 2 days. No, we messed somewhere. Yeah, yeah, we didn't write the right resources. B resource requirement is 1, right? So 1. What about C? Resource requirement is 4 and 3 days, right? So 4, and for activity D resource requirement is 3. Mm, what about next? Activity G, start on 1, ends on 3, 2 days, and resource requirement for G is 5. Okay, coming to the next. Activity E, 4, 6, right? And F is 3, 6. So activity E resource is 2, activity F is 6. So 2, and this is 6. What about activity H? Activity H starts on end of the day 5 till end of the day 7. So 6 and 7. And what is the resource? Resource is 8. So this would be 8. What about I? I starts I is on 7th day itself, you can see, and resource is 9. Similarly, J, 8, 9, 10, resource is 10. Yeah. So this is your for EST. This is your resource requirement for each activity per day. Now let's sum it up. 7. This is how much? 5 and 3, 13. What about this now? Again 13. This one 11, 9, 6 and 2, 8 and 8, 16, 17, 10, 10, 10. So what you will get is questions like this, that if it is if the activities are to start at the earliest start time, what is the minimum resource allocation, what is the maximum resource allocation, okay, or what is the resource allocation at a specific date, like date number 6. So your answer is at the 7, 17, 16, things like that. Okay, so now coming to another part, latest start times. Is it possible to give the latest start time without calculating? No, let's not make it more exercise for us. So let's do it. 10, 10 minus 2, 8. What about I now? This is 7 for G. 7. 7 minus 2 is 5. This is 6, 6, 4, 6, 3, 3, 1, 4, 1, 8, 4 is 4. Yeah. So you can see that for the activities A, C, D, E, F, I, J, which are on the critical path, it doesn't change, right? Which on the critical path? A, C, D, E, A, C, D, E, F also is on the critical path. Then I and J are also on the critical path. So there is no change. So change is only for which activities? Activity B, H and G. So what we do is, let's just change the color and write it. Okay, so for B, if we go by LS latest start, it would be end of the day 5 to end of the day 8, right? So LST is in green. Let me check again. Yeah, so this becomes 1 1 1 1. For H it becomes 8 and uh, yeah, last 2 days 8 8. For activity G it becomes 5 to 7, so 6 and 7, right? So if we sum it up, so what would it be? This was our EST total. Now for LST, if you calculate, it would be 7. In this case, one is already B is already shifted. So just a moment. We can't just go on removing one like this. Yeah. So for these 3 days, we won't consider this. G also has shifted. This is also shifted. So let's just sum it up. 4 plus 3, 7 now. For day 3, 7. Similarly, day 4, it comes out to be 10. For day 5, now you have got B starting also. So 1, 9. For day 6, you have got 9 and 5, 14. For day 7, you have got 6 and 9, 15. This 10 or 11 actually. Yeah, B is also there, right? Yeah, 11, 18 and 18. So what you can see is that when you are going for early start time, the resources were kind of loaded at the beginning, right? Like 13, 7, 13, 16, 15, 17 were kind of in the middle. But when you go towards the latest start time, it is loaded towards the end, 18, 18. So now the question is, prepare the schedule, obtain an optimized resource profile. So optimized resource profile, how do you, uh, using the float is what we have to do right now. You can see that the maximum, so how do you actually do it? What you see here was, in case of G, this was the complete available time, and you only had 2 days. You only had to do work for 2 days with 5 resources. So it could be moved here and there, right? So even if we don't change anything for B and B and H, right? Let's just shift. Uh, okay, so let me mark it for you. Yeah, this was for H and this was for B. So how do you actually use your float is the case here. One condition is that you cannot break down your activities. So is there any scope? Okay, so I will I will leave it for you guys because we have to discuss one more thing here. Uh, okay, so prepare the schedule if maximum available resource per day is 10. Okay, per day allocation of 10 resources. Let me just move the slides here and there so it's helpful. So we are now into resource allocation. And the limit is 10. So what are the rules? I mean, resource allocation, you just start allocating the resources to the activities and make sure that it doesn't exceed your number 10. So what should we do first is, let's just plot it. Again, we will do it in the similar manner, A B C D E. Okay, A B C D F G H I J, and this will be your total. 1 2 3 4 5 6 7 8 9 10 11 12. Okay, maybe, because it can exceed or cannot, we will see what happens. So day 1 consideration, day 1 into consideration, 0 to 1, right? Activity, only one activity is there, and resource requirement is 7. You can fulfill it, right? It is under 10. So 7, it is done. What about now, coming to the next? So initially, you know that your critical path is ACEIJ and ADFIJ. That was initially your critical path, right? So now the case is, which activities have to start on day 2? B, C, D and G. What is the total resource requirement? B is 1, right? So 1 plus 4 plus 3 plus 5. How much is it? 4 and 4, 8. 8 plus 5, 13. Okay, you cannot supply 13. So how much you can supply? You can supply only 10. If you can supply only 10, so who should get the first call? Who should be on the priority? So priority is on the first thing is that whichever activity or activities are on the critical path. See, none of the activities is running right now, right? So we have to start the new activity. So whichever activity is on the critical path, we will start that activity. So which activity is on the critical path? Activity C and D. So if you start both C and D, how many resources will it take? 7. Still there is some resource available, right? You have got a scope till 10. So what next can you start? Okay, obviously you cannot start with G. It has 5 resources, so it will skip. Yeah, so activity G, you cannot do it, the resources are less. So what you will do? Okay, let's start with activity B also. So let's do this. Activity B, we are starting. What is the resource requirement? 1. Activity C, 4, and D, 3. Now coming to day 3. Now see, what has happened is that G should have started, but you haven't worked on it, but rest of the 3 activities are continuing. So on day 3, while 4 activities need to be running initially, 3 are running, and for 4th you have not got any scope till now, right? So what you do is you continue B, C, D. What are the resource requirement? 1, 4 and 3. Okay, so this would be 5. Let's write the duration also. 1 plus 3, 4 and 3. So what so now day 3 is also over. Coming to day 4. Day 4, which activities could be running now? So day 4, you say that activity B is already going on, activity C is already going on. What other option do you have? Activity E is in line, activity G is in line. If you take activity B and C, 7 resources already in use. Sorry, 4 resources already in use. Day 4, let me write it out for you. Okay, so uh, yeah, B, C running, and G and E in line. So if you see, if there are like G and E in line, which activity should you start with? B and C running, that means how many resources have you utilized? You have utilized 5 resources, 5 is still remaining. 5 means you can fulfill for G also, for E also. But if you fulfill for G, it will take 5 resources and there won't be any resource left for E, which is your critical activity. So what you would do is, as E is your critical activity, you will give resource to E. How much resource does E need? E need 2. So let's do it for day 4, right? B is continuing, C is there, and E, how many resources does it need? 2. Still you have got G pending, right? So E is also starting day 4, it will go to day 6. Okay, just a moment, I missed this up. Okay, not E, you have to focus on, because you are on start of day, end of day 3, so you have to focus on activity F, right? So G and F are in line, and F, how much resources does F require? F requires 6. Do you have 6 resources available? No, you don't have 6 resources available, right? So if you don't have 6 resources available, definitely you cannot start with activity F. Then which activity would you go to? You would go to activity G. So F being critical, but resources are not available, so you cannot go to F. So you go to another activity in line, which is activity G. How much resources does G need? G need 5 resources. So let's do it. We are talking about day 4, right? So 5 resources. If you total it out, how much is it? This is 8, and this is 10. What about day 5? Day 5, you will see activity B is running, so you give resource to B. Activity G is also running, so you give resource to G. Now which all activities can start? Day 5, E can also start. E is on the critical path. F is on the critical path, but you don't have resources, right? So for F you need 6, for E you need 2. Do you have 2 resources? Yeah, you have already used 6 only, so you can use 2 resources here. So you give 2 to F. What is the total now? The total is 8. Your activity E is still pending, right? Now come to day 6. Day 6, what you can see is, see, E is pending still. For G, you know that you started when? You started at 3 and finished at 5. So this is 3 and 5. Now when you come to day 6, what can you see? You have got activity H in line. Let me write it out somewhere here, okay? Any activity that is running, yeah, activity F is not complete yet, so F isn't running, and activity is in line. You can say, as F is not complete. F is not complete. When did F start? Yeah, F started on day 4, end of the day 4. So this will finish by 7. So as F is running, you cannot start with I, but H is also in line now, right? Because B is complete. So H in line. So which activity can you do now? H, how much resources does it need? 8 resources. F is in running. F, how much resources? F is taking 6 resources. Do you have 8 resources available? No, you do not. So what you do is you postpone the other activities, right? F is 6 resources. Now, okay, we have been confusing it. Let me go back to day 5 again. I wish I had come with answers in this session. Okay, day 5. What is happening? Activity B is running, so you give resources to B. Okay, what else? It is day 5. Activity E is in line. What other activities are in line? Activity F is also in line, right? And activity G is also running. So that means for the running activities you have already used 6 resources. What about resources and activities in line? They both are critical, but E needs 2 resources. F needs 6 resources. How much resources are available till now? We'll say 4 are available. So 4 are available, so you can go forward with F, right? So 2 resources. So when second day itself, right? So you give no, we just discussed. It is for E. You have got 2 resources, so you can do E for 2 days and 2 resources. So how much is it? Again 8. Now if you go to day 6, which is running, only activity E is running. F is still in line. In line, how many activities are there now? E is there, H is E running, F and H are in line. If E is running, only 2 resources are being used. F, it needs 6 resources. H, it needs 8 resources, but F is on our critical path, so we will give preference to F. So when will F start? At the end of day 5, and we'll go till day 8. So let's just mark it for F, day 5 to 8. How much resources? 6 each. So on day 6 you have utilized 8. On day 7, what is the condition now? Or can we do activity H also? You have got 2 resources still remaining, but activity H will take 8 resources, so definitely you cannot do activity H now, right? Okay, so coming to day 7, which activity is running? F is running. Which activities are in line? Only activity H is in line. Remaining activities are complete, as you can see from this chart, right? So H is in line, but do you have the required resources? No, you don't. If you don't, then let's just complete F and we will see when the resources are available. So that goes on till how much? Till day 8, right? So 7 and 8, only activity F works. So F, resources 6. Now as you come to day 9, there is no activity running, but what about the what about the available, what about the activities in line? So you can say that H can also start and I can also start. I can start, right? H and I. Now, which of the above was in critical path? So you say I was in critical path, right? Your critical path still has not changed. This is only 2 days, so you could start it anyway, any now also. And see, you say that so many changes have happened till now. Why are we still following the same critical path? No, we are not. Actually, the critical paths might have changed, but if you see in this case, H could start at 8 also. What is the EOD today? So 8 plus 2 10, and it would be 10. And if I starts today, 8 plus 1 9, 9 plus so this would be 12. So 8 9 9 10. So again IJ is on your critical path, right? So your total duration, as this is giving you 12, so this is on your critical path. So which one will we give preference to? We will give preference to activity I. I resources 9 for 1 day. So I 9 resources, so total 9. What about now? At day 10, you have got two options, J and H, right? In line. There is no activity running, but we know that activity J is critical, right? Still, if you start with here, if you give it 9, 9 plus 2, 11, and this is 9 plus 3, 12. So J is critical. How many resources? It will take 10 resources for 3 days. So your total is 10, right? But what about now? After day 12, so day 13, inline, only one activity, H. So this actually comes out to be 12 and 2, 14. What is the resource required for H? 8. So 8, 13 and 14. So the total here is 8. Yeah. So now as you can see that the number of resources being utilized in 1 day is limited to 10 only, right? But so this is how you have allocated the resources. What has happened is that your duration has increased from 10 days to 14 days. Okay. So this kind of covers resource allocation for us. So you saw an example of resource leveling also and resource allocation also. Now coming to time cost relationship. Okay, first of all, the examples that we have, what we did was, let's say that you have to do 1000 cubic of concrete. Okay, plain cement. So how will you determine the duration? Okay, you would say, let's say I'm doing it manually. Okay, so manually if I use 3 laborers, 1 mason, I can, and they can give me 100 cubic meter per day, then that means your duration would be how much? 1000 by 100, 10. Okay, this was your first option. What if I say, instead of doing it manually, let's manual mixing. Okay, let's have a small mixer. So with a small mixer, it could give you 250 cubic meter per day. So what would be your duration now? You would say 1000 by 250 is equal to 4 days. And if I say Okay, let's just order RMC and get it from there. So they can supply you more than 1000 also. Let's say they're supplying you 1000 cubic meter per day. That means how many days will it take you? So you will say it will take me 1 day. Now this is the duration component: 10 days, 4 days, 1 day for the same activity, right? For the same activity, you have got three different durations. Which duration will you pick? Which one is more convenient to you, or as a contractor, which one is more profitable to you? So more profitable, how would you calculate which is more profitable? So in which activity, in which alternative, how much cost are you incurring? So let's say in first case, uh, you are incurring material cost, and material cost would be same for each, let's assume, or I would just give you some figures, random figures. Okay, so let it be 65,000. Okay, for this is the direct cost. Okay, for a small mixer, 75,000, and for RMC, 85,000. So if this is your direct cost, indirect cost, let it be 1000 rupees per day. So if you have to get the total cost for each alternative, what would it be? For alternative 1, it would be 65 plus 10 into 1000, right? So total would have been 75,000. For this second one, what would it have been? Okay, let me reduce these figures somewhat so that it gives a nicer picture. Okay, this is 75,000 and this is 67,000. Okay, now let's see. So direct cost 4,000. So the total cost would have been 71,000. And in this case, total cost would have been how much? 71,000 again. So which one will you prefer? You will prefer the one with lesser cost, either 2 or 3. But 2, for the same cost, it will take you 4 days. For the same cost, it will take you 1 day. So you might prefer, depending on the works, if you have some new work in line, you would prefer to finish it at the earliest. Or if you don't have anything in line, or it is somewhere down the line, so you would prefer to keep your staff busy. So you'd be like, okay, let me go with alternative 2. It is costing me the same, so no worries, right? So what you saw is, if you talk about time cost relationship in case of activities, yeah. So as your duration reduces, your cost increases. Okay, this is in case of activity. Okay, this may not be a straight line curve, this can be parabolic. Okay, I am not talking about the slope, I am just telling you that as your duration decreases from normal to if your duration crashes, your cost is going to increase. Okay, and this will be confusing, so I will just mark it here. Similarly, if you take a project, this is what happened. When you talk about activity, you're talking about direct cost only, right? So your direct cost increased, but your duration decreased. What about the whole project? So you might say that direct cost may follow the same curve, right? But what about indirect cost? Indirect cost, you will say that it reduces with time. So if you had to calculate IC, this would have been 10,000. In this case, it would have been 4,000. In this case, it would have been 1,000 only. So indirect cost. So indirect cost is increasing with time, and direct cost is decreasing with time. So somewhere along the lines, you will get a curve like this. Mm. So what you are actually interested in is this point. This is where you have minimum cost. So this is your minimum cost and this is your optimum duration. So how do you calculate this minimum cost and optimum duration for the networks that we have been working on? Okay. Yeah, before moving on, ma'am, would you like me to give a recap of what happened that you missed? Or should I just continue? See, this is a live session and I truly regret not taking it on the regular time uh, last Tuesday, but we are here now. You can hear me clearly, right? Okay. So, anyway, coming to the question part, the duration and direct cost for each activity in the network of a small construction contract, both under normal condition and crash conditions, are given in the following table. Uh, Establish the list cost for expediting the contract. So what they are asking you is, they are asking you to calculate this value and determine the optimum duration of the contract, assuming the indirect cost is rupees 125 per day. So what is the first thing that we do? You have been given a set of activities. The first thing that we do is we draw the network. We draw the network, we find the critical path. I mean, all these things remain the same. Topics change. We have seen this in case of resource leveling also, and now we will see it in case of crashing also. So first thing, let's draw the network. Is it somewhere visible what kind of network it is? Okay, let's start drawing activity on node network itself, right? So you have got A, then from A you have got B and C. B and C give rise to what? D, E and F, right? Yeah. So F, let it be somewhere here, and E is giving to G. Okay. So B is giving to D. C has got E, and then you have got F. What else? You have got G from E, right? So you have got G, and then D, F, and G. From these three, you have got H. Right. So network complete. Yeah, it seems so. So what can we do is, like, let's just move F on the inside. It might look a little better if possible. Are the relationships same for F? B and C, D, F and G for H. Yeah, it is the same. So network analysis, let's calculate the duration and the critical path, or this is the like this is the one thing that we have been doing every time, right? Making a network. Let's do it in a different manner. What uh, definition of critical path? Path with the longest duration, or the, yeah, among all the existing paths in your network, the path with the longest duration is your critical path. So what are the paths you have? You have got ABDH, let me write ABDH, then you have got ABFH, then you have got ACFH, and then you have got ACEGH. So what are the durations? So all you need to do is you need to keep the durations of these activities and calculate it. Yeah, this is going to be lengthy, but we will try to make some sense of this step. Okay, what about activity A? We are talking about normal duration right now. Okay, so it would be 12, 8, 23, and what is H? 12. You guys help me calculate the values. It would go faster in that way. Yeah, 12 at F is 20 and H is 12. So 12 and 20, 20, 43, 50, 55. This becomes 55. What about this? This is 20, 40, 52. What about this? 12. What about C? 15. F is 20 and H is 12. So this comes out to be 27, 47. Wait a minute, let me check. Yeah, 27, 47, 57, 59. And what about this? ACEGH. ACEGH is a path. Yeah. So so 12, 15. What about E? E is 5, G is 13, and H is 12. So 13, 12, 15, 15, 15, 30, 30 or 5, 35, 37, 47, 47. So which is your critical path? Right. So all this effort, and what you get is that your critical path is this one, ACFH, and other activities have some scope. What kind of scope? They have got some float. So next step, what is the next step? You calculate the crash cost slope. Okay, so what is cost slope? So cost slope is do you want to give me the what is cost slope? Crash cost minus normal cost divided by normal duration minus crash duration. So what we would do is we would calculate the cost flow for each of these activities. What is the way? You saw the formula. Let's just do it. This would be 200 by 200. I'm just writing the cost flow here. 100. This would be 300 by 2, 150. 600 by 3, 200. This would be 0, so you cannot crash it. What about activity E? 300 by 1, 300. What about activity F? 300 by 5, 60. What about activity G? 80, 80 by 2, 40. And what about activity H? 100 in 2 days, so 50. So this is your cost flow. So, and what is the total cost till now? Your normal cost. Let's just sum it up. 7 and 5, 12, and 4, 16, 16 plus 5, 21, 24, 20, yeah, 30, 32 and half, and this is like 50, yeah, 50. Okay, sorry, I don't know what happened. Yeah, 12,000, 12 and 4, 16, 21, 24, 30, 33, 35, 35, 500 is your normal cost, and this is your direct cost. What about indirect? It is how many days it is taking? 59 days, right? So uh, 59 into 125, how much is it? Yeah, 7375. So total how much does it become? Have we calculated it correctly? I think so. Let it be. Yeah, 42875. So let's plot it. This is step 0, duration is 59, crashing none. What is our direct cost? Direct cost is 35500, and indirect cost is 7375, and total cost is 42875. So now we have to start crashing. Crashing how? Our critical path is what? This one, ACFH now. So if you have to reduce the duration of critical path, you will have to, the only way is reduce the duration of the activities lying on the critical path. So which activity would you prefer? Which has the lower cost slope, right? So which activity has lower cost slope in A, C, F and H? A is 100, C is 200. These are per day, right? 200. F is 60, and H is 50. So which one would you like to reduce? You would say 50 sounds good to me, right? It is the lower one in all three. 50. H scope is how much? 2 days. You say that, yeah, in even if you reduce it directly by 2 days and ignore all others, there won't be any effect, but we will check it. So let's say you reduce H by 2 days, so this duration becomes 10, and your total for this path is 57. Similarly, this goes 10, this is 50. Okay, let's do one thing. We will do this calculation on a new page so that we can mark it step by step. Any query, anything you would like to ask me till now? Okay. So 4 critical paths. I will just write them a little bigger here. Okay, so we have got ABDH, then we have got ABFH, then we have got ACFH with ACEGH. Calculating the durations, 12, 8, I'm just writing it separately, 23 and 12. Similarly, 12, 8, 20, 12, 12, 15, 20, 10. Okay, this was not 10, this was 12, right? So 12, 15, 5, 13, 12. Yeah. So the totals were how much? 57. No, let us mark it here. 55. This was 52. This was 57, and this was 47, right? So step 1, if you reduce, we found out H had minimum cost flow, right? This was our critical path. H minimum cost flow, reduce its duration, 10, 10, 10, and let's see how does it change. This becomes 53, 50, 55, and 45. No change in critical path yet. So let's write it. Step 1, duration is 57 now. 59. So this was 57. Let me check it. Yeah, 52, 12, 23. Yeah, this is also correct. No, this one seems 25, 25 and 15, 40, 45, 47, 57. This was 57. Yeah, so 57. So this is reduced to 55 now. And this was 59. Now let us check this again. 12 and 15. Yeah. So now we have got a good starting space. Crashing. Which activity did we crash? H. H by 2 days. So how much did your direct cost increase? Your direct cost increased by no scope in H now, right? 2 days you used it. So 100 rupees it cost, and you saved 125 rupees. So this was plus 100, and for 2 days you saved 125 rupees. So minus 250. So minus 150. How much would it be? 42725. Yeah. Now coming to the next, you cannot work with H now. Okay. D and H you cannot work with. So now the critical path is still same. ACFH. H you cannot do. ACF, which one has more scope now? You will say 60, 6, because A is 100, C is 200, F is 60. So we will go with 60. F, how much scope is there? 5 days of scope is there. So let's try to reduce F by 5 days. Can we do it? So if you see here, if you reduce this by 5 days, okay, so 12, 15, 20, 12, and so 57. So after, from 57 it would come down to 52, but there is no change in ACEGH. This is 55, so this will be critical. So what we do is, we don't move 5 days, we just reduce it by 2 days. Okay, so let's change F by 2 days, so that it would be 55 and 55 the same. and we will see later. Okay, this was 57, so 55 f by 2 days plus 120 minus 250. We'll calculate it later. Okay, so let's do it. F by 2 days, so this becomes 18, this also becomes 18, this is same. So how much is it? This becomes 55, 48. Yeah, and still now you have got two critical paths, ACFH and ACEGH. Now if you compare these two and you have to compress it, you cannot. Okay, let me write it clearly. ACFH, ACEGH. H you cannot do, right? So what can you do? Either you compress A, so both these will be compressed. Either you compress C, crash C, both these paths would be crashed. Or you make a pair, you crash any of the activities F and E or F and G and see what happens. So what will govern? The governing factor is again the cost, right? So if you crash A 100, C 200, what if you pair F with anything else? Okay, how much is the crash cost for E? E is 300 and G is 40. So F and G 40. So 40 plus 60, 100. So F and G is one pair and A is one. So either you go by A or F and G. They both are same, right? 100, and this is also 100. So what we'll prefer? Let's say we go by A. It is the first activity, so let's just get it done with. Okay, so we will go by A, and how much can we crash A? We can crash it by 2 days. You say it is on every network, so we don't have to worry about it much, right? So A by 2 days, if you do it, cost is how much? 100 into 2, 200, and reducing it would be 125 into 2. Yeah. So step 3, A by 2 days. So this would be plus 200 minus 250. And what would be the duration? Duration would be 53. So let's do it. This would become 10. So this would become 51. This would become 10. So 46. This would become 10. So this would be 53. 10, 53. Again the same thing. ACFH, ACEGH, and we have already made the pair F and E. You can compress, but by how many days? You know that ABDH is on line 51 days. So let's say if we compress F and E by 2 days, do we have the scope? Sorry, F and G by 2 days. Yeah, F we already compressed by 2 days, and still there is 3 days scope. So F you can compress, right? F that is still on 18, that can go till 15, and G is still on 5 and it can go till, okay, let me check. Yeah, G is on 13 and G can go till 11, so 2 days. Yeah, you can do it. So let's compress F and G. F and G by 2 days. Let's see what happens. F by 2 days, that means this is 16 now, so 44, and this is 16, so 51. This G becomes 11, so 51. Again the same two critical paths, but you have now used out G, and F on 1 day scope is remaining. Let's mark the cost. Plus 200 minus 250, and duration is 51 days. This is the step 4. Okay, So now you have got three critical paths, as you can see. What are the three critical paths? ABDH, ACFH, and ACEGH. And out of these three critical paths, A you cannot compress. You have already crashed it. H you cannot crash. You already done it. What about other activities? There is no scope in D initially. A and G. Yeah, let me write it here also so that we don't forget. Yeah, G also there is no scope. So what you have got? If you have to crash it, you have to make a pair of B and C or B, F and E. And how much scope they have got? Let's check. B 2 days scope, cost of 150, and if you pick C, how much is it will be? It would be 200, and it has got some scope. So 250 plus 200 plus 150, 350, right? So one option is B and C, cost is 350. What is the second option? B, E and F, what will be the cost? B is 150, E is 300, and F is 60. So 450 plus 60, 510. 510. So obviously you will be preferring which one? Option 1. Option 1. Now how much scope have you got? If you reduce all these by a couple of days, still there is no view of another path coming in, right? So how much scope do you have? B and C, B you can reduce by 2 days, right? So let's do this by 2 days, B and C by 2 days. B and C by 2 days. What will be the cost? Plus 700 minus 250, right? And let's calculate the duration. Okay, so right now all these are of no use to us. Let me rub it off. Yeah, so B by 2 days, so B is now at 6, so this duration become 49. B is at 6, this duration has become 42. C by 2 days, so 13, this duration become 49. C by 2 days, 13, so 49. So that means again you are now you have used whatever was there in B. What is remaining now? Again your critical path is same, ABDH, ACFH and ACEGH. So you knew what was the alternative. If you see, you already consumed whatever was available. You cannot compress A again, you cannot compress B again, you cannot compress D, and you cannot compress H. So this is the final crash. I mean, A you have crashed, B you have crashed, D you have crashed, H you have crashed, no scope. So 49, you cannot reduce your duration to less than 49 now. So is there any sense of moving forward? No, there isn't. So let's just calculate these things. How much does this come? 120 minus 125, so this is minus 130, so this becomes 42595. What about this? Minus 50, so 42545. Same, minus 50, 42495. What about this? This step, this is like plus 450. Yeah, let me check. Yeah, so this becomes 42945, 450. Yeah, so you have got cumulative cost now, and this is the final crashed version, 49-day. So if you plot it for to for 59, it would come. What kind of curve are we getting? We'll just check the curve. 42875, then somewhat reduced to 42725, then 425, then again reducing till what are we reducing? 1, 2, 3, 4, and 5. Fifth is very close but still reducing, and then we have got a jump that brings us to more than what was initial cost, right? So this becomes a curve like this. This is how much. Okay, let me place it near only. Yeah, so 49, 51, 53, 55, 57, and 59. So your optimum cost, sorry, minimum what is your minimum cost now? So your minimum cost is rupees 42495, and optimum duration is 51 days, and your minimum duration is that you have also calculated 49 days. Okay, so yeah, this kind of answers our question. Okay, so this is kind of the end of the session. So let me do a quick recap of what we did. So we had three main things to discuss in this session. Project monitoring and control. We didn't talk about systems much. Yeah, resource scheduling and crashing. So what we saw was, the first example that we saw was of monitoring. But for monitoring, the first thing is that you should have a baseline. I mean, monitoring is checking what is happening, and still if you don't know what was supposed to happen, then how are you going to compare it? So the first thing is you should know the baseline, and from the planned work, we saw how to create a baseline, we saw how to plot the S-curve, and then you were given two scenarios at end of the month 3 and end of the month 5. Cost incurred was given to you, and then you were asked to calculate, are you under budget, over budget, ahead of the schedule, behind the schedule. And so how did we calculate it? So for both these cases, we calculated the cost of work, budgeted cost of work performed, and okay, budgeted cost of work performed, then there was actual cost of work performed, and budgeted cost of work schedule was from this table, and we compared all these three and commented on it. Then we went into resource leveling versus resource allocation. So resource leveling, what did we do? We saw that when we were planning and when we were doing our network analysis, we were happy with our critical paths. We didn't quite take care of the resources. We are like, okay, let it be. Whatever the resources, we have assumed that they are available. And then we tried to plot the number of resources required each day or for each quantum unit of time that we are working with. Now, the thing is that not each and every resource is kind of critical that we need to take care of, and there are a lot of resources being used. So this kind of a system, what we did right now in this session, resource leveling, resource allocation, only taking care of one type of resource, one critical type of resource that we decided that okay, if we manage this, then we are happy. So what we did was, what we saw is that there can be a resource loading chart of any curve with humps and with troughs and crests, just like Himalayas. But we won't like it. We would be more happy if it is a plateau, right? So how do we just compressing it, just like reducing the peaks and increasing the troughs? You have got what you have got is you have got resource leveling, but it might be a case that whatever the number of resources you require, it is not available. So when you have to work under a fixed constraint, what you do is you allocate the resources on some basis, and we also saw how to do it. So we were given a project, 10 activities. Yeah, 10 activities, a small project only because it completed in 10 days, and resources were given. So what you had to do was you had to determine the resource profile for this project. If activities are to start on their early start time, late start time, and obtain an optimized resource profile. So, and also to prepare a schedule if maximum available resource per day is 10. So just a simple network analysis. We got the early start time, late start times, and we plotted it. What we saw was two resource profile, 7, 13, 13, 11, 9, 16, 17, 10, 10, and similarly for the late start time also you got another profile. Now what you can see is that in this case also there are valleys, then there is some low lying area, then again a bigger peak, and then again some low lying area, right? And the same thing happens in case of LST also. So this is not the situation that we want. How to optimize it? I have showed you that okay, use the floats and uh, shift them here and there. Or for this situation, there are some algorithms like minimum moment algorithm. You can, for each shift, you can calculate the improvement factor and decide whether to do it or not. Okay, so now then we moved on to resource allocation. The number of resources were fixed to 10. Now how do you decide which activity should we allocate the resource? So we saw that if each and every activity was starting at the early start time or latest start time, there was going to be over allocation of resources. So to avoid that, there are some basic rules, basic heuristics that we applied in this session. Here is what rules. The first one was जो चल रहा है उसको चलने दे. The activities that are in running, you keep them running, you finish them first. Then the second rule, जो critical है उसको पहले करना है, जो critical है उसको पहले priority देना है. So once you have seen which activities are running, you give the resources to those activities. Then the activities that from the remaining activities, from the available activities, you see which is on the critical path and you allocate resource to that. But you should see that when you are allocating the resources like this, your critical path keeps on changing, so you have to keep in mind. Now you have allocated resource to the critical activity itself also. What next? So next what you can do is, next you allocate to activities that at the early start time. So जिसको जल्दी शुरू होना था उसको आप पहले शुरू कर दें. एंड वही केस है, अगर उसको बहुत देर से लटकाया रखा है, बहुत देर से आपने रिसोर्सेज नहीं दिए हैं, सो यू allocate resources at that activity. And what happens if two activities had the same early start time and they both have not got resources? In that case, what you do? You allocate to someone that has less float, that has more scope of more scope of getting adjusted, you adjust it, right? So yeah, these are the four basic rules that you have to use. And with that, we did it on the day by day basis, and this is what we got our resource allocation or resource profile for each day. Your duration also increased from 10 days to 14 days, and the schedule, as you can see, this is the schedule here I have marked, right? So this is how we did resource allocation. Then we went into time cost relationship. Time cost relationship, one of the most in focus things whenever we discuss. Yeah, this kind of thing can be easily done on softwares now. The previous case that you saw of resource allocation, that is a case of optimization and not of linear programming. That you can there are some solvers that are trying to optimize it in a better way. uh, the previous example was of a good case to apply genetic algorithms to our studies, our practicalities for civil engineers. Now coming to time cost relationship, you have got each activity where we saw just one example of how direct cost could increase and indirect cost could decrease with time. And we saw in case of activity also, in case of project also. So as a contractor, what you are worried about, what you are interested in, you are interested in having your profits maximized at what cost? Definitely, right? You just want to minimize your cost. So we saw that we have to minimize the cost, and for this we did a numerical. What were you given? You were given normal, normal duration, the crash duration. Also, there was no other condition given. So what what you assumed was that for activity A, let's say the normal duration is 12 days, and normal cost is 7,000, and crash duration is 10 days, and crash cost is 7,200. So you assumed a linear relationship between both these points. So if you finish it in 11 days, it would have cost you 7,100. So on the similar phenomena, you calculated cost flow for each activity. And then what you did, you made a network, you found out the paths. We tried it in a little different manner. We calculated different paths. What are the paths we had? We calculated the durations, and from that we determined what is the critical path. For the critical path, we started crashing. Right. So crashing, first step, our critical path was ACFH. Then we reduced H by 2 days. The duration became 57, and similarly some other as H was the end activity in all paths got reduced by 2 days. Next, for ACF, we saw that F had a scope of 2 days, and we reduced by F by 2 days. Again, there was no other. Now, as soon as you reduce F by 2 days, you saw that there are two critical paths now, ACFH and ACEGH. A being the common, you reduced it by 2 days, and similarly, you did it. We could see that instead of going day by day, we could jump 2 days in this time in each case, and saw how the duration changed. And similarly, we plotted the change in direct cost, the change in indirect cost, and the cumulative cost. So we plotted the cumulative cost curve. So this is duration, and this is the cost. So from this point we got minimum cost and optimum duration, and also the minimum duration. Yeah. So any questions? Okay, so this brings us to the end of this session. Hopefully, those who are watching it on YouTube find this useful. If you have any doubts, you can write it on the discussion forum, and I would check that. And for this course, I would see you on this Tuesday. It won't be postponed. And for the other course, we will be having a session tomorrow, and the topic we discussed right now, the second one, resource leveling, resource allocation, that will be discussed in detail tomorrow in project planning and control course. Yeah, thank you guys, thank you for being with me. Signing off. Bye.